Section 1.5 is called Properties of Real Numbers. There are three basic properties we're going to be working with: the commutative property, the associative property, and the distributive property. In your textbook, Section A on page 115 is the commutative and associative properties. Since the textbook talks about these in the same section, I'll do the same here, but I'm going to start by talking about the commutative property, and then I'll talk about the associative property. Something else to keep in mind is that the commutative and associative properties each applies to both addition and multiplication. Here's an addition problem. 3 plus 5. The answer is 8. But we're not interested in the answer. We're interested in the actual problem. What the commutative property says is that instead of 3 plus 5, I can write 5 plus 3. That's the commutative property of addition. Each side of this is equal to 8. That means I can do the same thing for two variables. Let's use a and b this time. A plus b is going to be equal to b plus a, no matter what a and b are, no matter what their values are. This is called a generalization of the property we found using 3 and 5. In other words, this works for 3 and 5, but does it work for every pair of numbers? Does it work for 4 plus 7? Is 4 plus 7 equal to 7 plus 4? Well, of course it is. And therefore, it doesn't matter what A and what B are, the property is always going to hold true for any two numbers, any two real numbers. The way I remember what this is called, especially as we start to compare it with other properties, is I think that one way to do their job for 3 and 5 is for them to commute to work. Here, 3 is in the first position. It can commute to the second position. And 5 can commute from the second position in the addition problem to the first. In other words, they change places. They commute to work. This is the commutative property for addition. There's also a commutative property for multiplication. Here's what that says. Let's look at the problem 3 times 5. Since the commutative property of addition says that you get the same answer whether you add the 5 to the 3 or the 3 to the 5, then it seems to make sense that the commutative property for multiplication would say that if you multiply 3 5 times, you'd get the same thing as if you multiplied 5 3 times. And in fact, we know this is true. 3 times 5 is 15, and 5 times 3 is 15. The commutative property for multiplication says that A times B is equal to B times A. In other words, for any two real numbers, the order they're in, the position they're in when you multiply them, doesn't matter. You'll get the same answer. Again, I like to think of this as the numbers commuting to work. Here, 3 commutes from the first position in the problem to the second position, and 5 commutes from the second position to the first. So the commutative property says that changing the order that you do the problem in does not affect the result. The commutative property of addition says that the order that you add numbers in does not change the sum. The commutative property of multiplication says that the order that you multiply the numbers in does not change the product. Now, of course, as promised, let's talk about the associative properties. Let's do this one by looking at an example as well. I could take 1 plus 6, for example, and then add that to 8. Order of operations tells me I need to do what's in parentheses first, and then add the 8 afterwards. I get 15. But what if I had 1 plus 6 plus 8, like this? Well, order of operations again tells me that I have to do this first. 6 plus 8 is 14, and 1 plus 14 is 15. Notice that the results are the same. What I'm saying is that in general, I can add two numbers and then add a third. Or I can add the result of a sum to a number. That's the associative property of addition. When I took algebra, I remember finding it difficult to remember what the associative property did as compared to the commutative property. When I talked about the commutative property, I mentioned that it was like the numbers were commuting to work to do their jobs. They moved. Notice that here, the numbers don't move. The 1, the 6, and the 8 are in the same positions as they were before. But in this example, the 1 and the 6 are associated. They're grouped together. You could say they were hanging out together. On this side, however, it's the 6 and the 8 that are grouped together. They're associated. The associative property says that it doesn't matter which numbers you associate first and then add the result to a third number. If all three numbers are the same, you'll get the same result. The associative property works with multiplication too. If I took 3 times 2 and multiplied that by 5, I would get 6 times 5, which is 30. On the other hand, if I took 3 times 2 times 5, I would have to multiply the 2 times 5 first. That's 10. 10 times 3 is still 30. 30 equals 30, so these two are also equal. The associative property of multiplication says that you can do your multiplication problem in any order, as long as the three numbers involved are the same and the only operation you're doing is multiplication. The associative property of addition says you can do your addition in any order, as long as the same three numbers are involved and all that's involved is addition. Notice here I'm not combining multiplication with addition or division. In this example, I'm not using any addition or subtraction. It's only multiplication. Multiplication can be done in any order, as long as it's the same three numbers and only multiplication is being used. Addition can be done in any order, as long as it's only addition and the same three numbers are involved.